Here we have second rule to determine integrating factor. If the differential equation m dx plus n dy equal to 0 is not exact differential equation and is of the form y into f of xy dx plus x into g of xy dy equal to 0, such that if value of this expression is non-zero, then integrating factor will be equal to 1 over mx minus ny. Here we have an example. The form of this differential equation is this form, and we have to check whether this differential equation is exact or not. Here m is equal to y into f of xy, which is this one. Similarly, n is equal to x into g of xy, which is this one. We can check value of del m over del y and del n over del x. Both the values will be unequal, hence this differential equation will be non-exact differential equation. Since it is non-exact differential equation and form of this differential equation is like this one, so we have to calculate value of mx minus ny. If it is non-zero, then this will be the integrating factor, hence we calculate value of mx minus ny, value of m and n. So here we see value of m and n. After simplification, we get 2xy cos of xy, which is not equal to 0, hence integrating factor is equal to 1 over mx minus ny equal to 1 over 2xy cos of xy. Now this is the integrating factor. If we multiply the given non-exact differential equation by this integrating factor, that differential equation will become exact one, and we will be able to find the general solution. So multiplying that differential equation by this integrating factor, here we see multiplication of the differential equation by the integrating factor. Now simplifying, this is the simplification. Now we have to further simplify this differential equation by multiplying both sides by 2. So this 1 over 2 will be cancelled, and this will be the simplification. Now this part is m and this part is n. Now we have to differentiate this equation with respect to partially with respect to y. So in case if we have to differentiate with respect to y, then we will treat x as constant. Here we have product of two functions, so we will use partial derivative with respect to y, and the rule will be product rule. This 1 over x with respect to y will be equal to 0. So using product rule for the first term, this is the product rule for the first term. This is derivative of the second term, which is 0, and this is the simplification. Now we take partial derivative of n with respect to x, differentiating partially n with respect to x. Here we have product of two functions, so we will use product rule, and 1 over y with respect to x will be equal to 0. This will be 0. So here we see product rule of derivative, and del over del x of 1 over y is 0. Simplifying, this is the simplification. Now this is value of del n over del x. This is value of del n over del x. Value of del n over del x is equal to this one, and this is also value of del m over del y. Hence the given equation is exact differential equation. The general solution is integral of m dx, where y is constant, plus integral terms from n with no x dy is equal to c. Putting the value of m, this is value of m, and this is that part of n which do not have x. This is the part of n which do not have x. Now we have to simplify the problem. Integration of first term, integration of second, integration of this one, this c is again here we can write either c or log c. Now this is f dash, so we can use rule integral of f dash divided by f is equal to log of f. here integral of f dash divided by f is equal to log f. Similarly, here we have log y and here we have log c. This minus will be placed here, and we can write cos y with minus 1 as 1 over cos y. We can further write in this way. Now log of a plus log of b minus log of c is equal to log of d. So these two will give log of x secant xy divided by y is equal to log c, cancelling log. This log and this log will be cancelled. This is the simplification. This secant will be placed here, multiplying both sides by y cos xy. So x is equal to cy cos xy is the general solution. This is the general solution.